In this video, we're going to go through all of the different machine learning artificial intelligence models, all of them. So if you can keep up with this 10 minutes lesson, if you can avoid the temptation to go back to YouTube and start watching unicorns and butterflies, if you stay for the 10-minute, I promise you that by the end, you can be able to say that you know all of the different machine learning artificial intelligence models. Not only that, you're going to be able to say that you understand which model is applicable for what specific problem. If somebody comes and gives you a data file and asks you to identify a specific function, specific problem, you're going to know instantly what machine learning model is the most appropriate for you to resolve that task. If you like this kind of videos, please click the subscribe button. I need 1,000 followers and then YouTube would monetize me. Apparently, they're going to pay me like £3 for every 1,000 likes or for every 1,000 views. I don't know. If I'm going to find out once that happens, and I will let you know. At the moment, I have 3 followers. So I only need 997 more followers, and then YouTube is going to monetize my YouTube channel. Now, on this slide, what we can see, it's a diagram, a chart explaining the most popular and the traditional machine learning algorithms. They're not only the traditional, these are just the most popular and the most traditional models. Let me first explain how this chart operates so you would be able to understand it. Each of the algorithms is classified based on is it supervised learning, unsupervised learning, or reinforcement learning, and they have a cover. But they also, each model has a shape, dimensionality reduction, for example. And we spoke a lot about dimensionality reduction and reinforcement learning, supervised and unsupervised learning in lesson 1. So if this doesn't make sense, go back to the channel, click on lesson 1. This is lesson 4 or 5. So go back to lesson 1, listen to that, and this will start making sense. It's only like a 5-minute, the lesson 1. But what does the shape mean? So let's say if we see this is a shape of a star, the same. No, that looks more, this is more of a decision-making star. So this would be a decision-making model, and since it's in green, it's going to be reinforcement learning. Now, that is a plus sign. So the plus sign here is a clustering. And since it's orange, that is unsupervised learning model. So depending on the cover, so this is a blue cover, that is a supervised learning model, and it's a square. So the square is here. So that's a classification, a regression model. And with that key, we're going to be able to analyze the most popular and the most traditional models and categorize them into that form of supervised, unsupervised, or reinforcement learning. Also, there is this level of complexity, from 1 being the lowest, from 5 being the highest. So here is the highest. And what are the lowest artificial intelligence machine learning models in terms of complexity? Well, as we can see from this chart, it's the linear regression and the logistic regression. By the way, this chart is designed by myself, so you won't be able to find it on the internet in other places. It's just something that I designed for this specific lesson. It's not something that I copied from the internet. So the linear regression is the most less complex, and the logistic regression is also on the same level. If we move up to the level of complexity here, we can see that we have 3 models that they are more advanced than the linear regression and the logistical regression. So those are decision trees, which so far all of those belong to the supervised learning models because they are in blue cover. So the linear regression, logistic regression, and the decision trees, those are the lowest on the complexity level, and they all belong to the supervised learning models. With the key means that belongs to the unsupervised learning, and it's a clustering algorithm. PCA, it's unsupervised learning, and this is a dimensionality reduction algorithm. Then we move to the more complex models. Those are getting closer to the more complicated models. So we have Q-learning, and actually Q-learning is probably going to be the future of artificial intelligence in the next few years. Q-learning is it's reinforcement learning, as we can see here in the green cover, and it's a decision-making algorithm. So the Q-learning with reinforcement learning means that it does not require data. It means that it's learning from the environment. This is a robot walking on the street and encounters a tree. Something happens with the tree, learns from that interaction and feeds back to the algorithm. So it does not require to be trained by data. On the most complicated models here, we have neural networks and DQN. So, but in my opinion, the future where we are going to see the most input would be the Q-learning. Now, let's look at, these are just the most popular and the traditional models. Now, let's look at all of the different models that they exist. So, in terms of the supervised learning models, we have the linear regression, and within the linear regression that speaks basically we spoke a lot about the linear regression in lesson number 1, but let's go through it again. What does linear regression do? It predicts a continuous outcome variable based on one or more input features. So you need to have at least one input feature, and assumes a linear regression between the input and the target. That's basically the description of a linear regression. What implications? When is linear regression used? So the basic principle and the applications. It's used in forecasting. So financial forecasting, for example, in any field that predicting continuous variables is required. So that's the key word here, continuous variable. Number 2, in the supervised learning. So here we're still in the supervised, and all the algorithms here would belong to the same group, supervised. So we're going to categorize them according to the lesson 1. Here are supervised, then it would be unsupervised, and then it's going to be reinforcement. Those are the 3 categories. So we're going to go through the category number 1, then category number 2, and then category number 3. There's going to be quite a lot of algorithms here. So the second algorithm in the supervised learning is the logistic regression. And the basic value of logistic regression is that it's used for binary classification. So it's input of 0 or 1, true or false. That's the binary values of the logistic regression. What's the implication for logistic regression? Spam detections in emails. So phishing website detection. That's where in cybersecurity, that's where logistic regression is used. The third algorithm is the support vector machines. Support vector machines, the basic value of support vector machines is to find the hyperplane that best separates classes in the feature space. And what's the implication of support vector machines? Face detection, classification of images, bioinformatics, for example, for cancer classification. Those are the uses for support vector machines. And here, if we want to end it here, most lessons would say those are sufficient because those are the most popular supervised algorithms. But there is more. There's a lot more. So under 4, we have naive Bayes. Naive Bayes is basically based on the Bayes theorem. It assumes independence between predictors. So, and the implication for this would be, again, email spam filtering, sentiment analysis, and classifying news articles, for example. That would be one of the implications for native Bayes. Fifth algorithm in the supervised learning algorithms is the key nearest neighbor. So key nearest neighbor is usually written KN, and there's another very similar key mean algorithm which most frequently is confused, but that's going to be here in the unsupervised. So the key nearest neighbor basically classifies a new sample based on the majority of class in its K, nearest neighbor. So basically it's looking for the nearest neighbor. What's the application? Recommender systems. So if recommender systems are the YouTube favorite algorithm, TikTok favorite algorithm, Amazon's favorite algorithm, big enterprises, they really like recommender systems, which are the key nearest neighbor, because they can recognize patterns and data imputations. So they can recommend you a new YouTube video based on what you liked, and then based on that they're gonna learn and recommend another one, and that's how they keep your attention. Or with Amazon, they know what you want to buy, so they're gonna keep pushing products that you might like and sell you more products. That's the fifth algorithm in the supervised learning category. The sixth algorithm in the supervised learning category is neural networks. So the neural networks, it's inspired by, the algorithm is inspired by the human brain and consists of interconnected units, neurons, working together to solve a complex problem. That's the basic explanation of the neural networks. In what application is the neural networks used? Image and speech recognition, so natural language processing, that's the areas where neural networks are mostly used. Seventh algorithm is the ridge regression and lasso regression. So ridge regression and lasso regression. The basic explanation of those two is that the variants of linear regression, they are variants of linear regression, but with regularization. So ridge uses layer 2 regularization and lasso uses L1 regularization. What applications are those two used in? Mostly where motor collinearity is a problem. So for model selection. The eighth model is decision trees and random forest. Well, this is a very, very widely used approach. And the basic value of decision trees is that they split the data into subsets based on the feature and the value conditions. Random forest are ensemble of such trees. So there's basically a lot of decision trees. What application is decision trees used in? Fraud detection, in finance, intrusion detection in cybersecurity. So they have many various different uses. Actually, it's probably one of the algorithms that I use mostly, that I have used mostly in the past. In industry setting, in academia, we work with more technical algorithms. The ninth algorithm, this is the gradient boosting algorithms, and this is where probably I should end it with supervised learning, because with the gradient boosting algorithms, there are a lot more algorithms in this category. So for example, the HG boost or the light GBM or the cat boost. So those are all within the same category of gradient boosting algorithms. How do they function? What do they do? Basically, they combine multiple weak learners, typically decision trees. So decision trees are not very good for learning. So typically they combined multiple decision trees or multiple weak learners to create a strong learner in a sequential manner. So they connect, they're correcting the previous errors. So if one decision tree made an error, then in the second iteration it would be corrected. What are the applications? Well, the applications are highly versatile in this area. They're used in ranking algorithms like web search engines, classification problems in various domains. But I think this is a good stage to stop with the supervised learning algorithms because we have exhausted all of them. That's the end of the supervised learning. Now we're moving to the unsupervised learning. And the first one here that we need to mention is the k-means clustering. With the k-means clustering, the basic principle is that it partitions the data into k distinct clusters based on feature similarities. What's the application? Market segmentation, document clustering, image segmentation. So it has the k-means K-means clustering has various different applications. The second algorithm in the unsupervised learning category, so we are in the second category now. The second algorithm in this category is the principal component analysis, PCA. We mentioned this quite a few times, and it's included in the diagram. So if you scroll back in the video, in the diagram, you'll see the PCA. So the principal component analysis, what does it do? Basically, it reduces dimensionality, and it's a technique for reducing dimensionality, then transforms data into fewer dimensions and still retains most of the variance. That's what it does. What's the application? The application is mostly it's used in exploratory data analysis, when you try to explore new data sets to reduce the noise in the data and to visualize complex data sets. So if you have a big data set that you don't know what to do with it, you can't make heads and tails, you would start with the principal component analysis, and then you might decide to apply for a different algorithm. But with the PCA, you would be able to visualize the complexity of the data set. The third algorithm in the unsupervised category is hierarchical clustering. Hierarchical clustering. With this algorithm, you can build a hierarchy of clusters where each node is a cluster consisting of clusters of the daughter nodes. And the implications for this algorithm is that it's useful in biological data analysis, like constructing pyogenes or gene expression and analysis. So this is very much in biological data. And there we are, slowly you're learning which algorithm is applicable for which use case. The fourth algorithm in the unsupervised learning algorithms is the density-based spatial clustering of applications with noise. And that's a very long name. We use abbreviations for this one. DBS-CAN, which stands for density-based spatial clustering application with noise. So that's a very mouthful algorithm. What does it do? It clusters points based on their density distribution. That's the whole purpose of this algorithm. What's the application of this algorithm? It's used for identifying fraudulent transactions in cybersecurity and for spatial data analysis. The fifth algorithm in the unsupervised learning algorithm category is the T-distributed stochastic neighbor embedding, which is another mouthful, and it's usually abbreviated with TSNE, which stands for T-distributed stochastic neighbor embedding. What does it do? It's a non-linear dimensionality reduction technique, ideal for visualizing, again, just if you want to visualize high dimensional data. What's the application? So the applications for this is the data visualization, especially in bioinformatics. That would be the main application for the TSNE. The sixth algorithm in the unsupervised learning category is the association rules, and one of those is called a priori. Second one is called EQUAT. Those are just different algorithms in the association rules category. What is the purpose of this algorithm? It identifies interesting associations and the relationships between data sets. That's the purpose of the algorithm. That's what it does. What's the application of this algorithm? If you're trying to apply this algorithm in practice, it's usually for market-based analysis and cross-selling strategies. So it's enterprise, industry-based algorithm. So for sales and market analysis. The seventh and the last algorithm in this unsupervised learning category is the anomaly detection. And here there are multiple different algorithms that you can use, but let's say isolation forests. Desolation forests. That's one. That's 7.1. Or 7.2 would be one class support vector machine. And what is the purpose of these types of algorithms? The anomaly detection algorithms, in the name actually tells you what it does. It identifies rare items of events that raise suspicious. They're different. So if they are different significantly from the majority of the data, they would raise suspicion. And that's what the algorithm would detect. What's the implication of an anomaly detection algorithm? Mostly fraud detection and monitoring systems in cybersecurity. So we have exhausted all the different algorithms in the unsupervised learning group. Now we're going to the most interesting category, which is the reinforcement learning. With the reinforcement learning, what does it do? Basically, it involves an agent that can learn to behave in an environment by performing actions, such as seeing the results. So one application of reinforcement learning is the game AI. So we had the AlphaGo. AlphaGo. That was one very famous algorithm. But in cybersecurity, these machine learning algorithms are crucial for threat detection, anomaly detection, predictive analytics, these various different applications. Apart from the basic framework of reinforcement learning, what algorithms are most promising? Well, we said I'm very enthusiastic about the Q-learning. And if you are going to focus your time on learning any one algorithm, this could probably be the one to focus your attention to. What is Q-learning? It's a model-free reinforcement learning algorithm that learns the value of an action in a particular state. When is it applied? Robotics, gaming, and AI video games. But my main area is in robotics, because I believe that's where it has more promising value than in gaming. Let's call that the first algorithm in this group. The second algorithm is the deep reinforcement learning. So they are commonly called as deep Q networks. What's the deep reinforcement learning? Basically combines neural networks with a reinforcement learning frameworks, allowing the algorithm to learn from unstructured data, unstructured input data. So what are the implications of this? Advanced game playing, like AlphaGo, which we mentioned earlier, and real-world robotics. The third algorithm in this group is the policy gradient method, and one popular method in these policy gradient methods is the reinforce. And reinforce is basically a method that optimizes the policy directly as a parameterized function concerning the expected return. What is the implication of reinforce? The same like the previous two, robotics control, but also it differentiates because it's also used for automated trading system. So all of those are used for robotics, but the first two are also into gaming. And this algorithm, policy gradient method, is for trading. So robotics and trading. The fourth algorithm in this category is the action critics method, which basically combines value-based and policy-based reinforcement learning using two models, one for the policy for the actor and one for the value function for the critic. And the application of actor-critic methods are complex control tasks in robotics, AI, and in simulation environments. Now, having ended here with the supervised, unsupervised, and reinforcement learning algorithms, Before we move into the next section, there are also what they called some hybrid models. And hybrid models are combining different types of algorithms. For example, using both supervised and unsupervised techniques. And this can sometimes provide better results than depending on the problem. Another last algorithm that I need to mention to make sure that I stay with the promise that I said that we're going to cover all the different artificial intelligence and machine learning algorithms. The last one that I want to talk about is the custom algorithms. So in research, especially in fields like AI and cybersecurity, quite often we need to develop custom algorithms that are tailored to specific problems or a data set. And this is the area that I work mostly. And this is probably the most specific category, because you're building an algorithm that is very useful for what you need to do today, might not be very useful for anything else in the future. So those are the most time-demanding algorithms, because quite often you cannot just take a few algorithms and put them together. You have to find a way how to integrate them. They're very time-demanding and they're very useful for a specific problem or for a specific data set. They're not very useful for anything else. This concludes all the algorithms, all the AI and machine learning algorithms that they currently exist. And now you know all of them and you know which one, what purpose do they serve. There we are. Before we end the session, just wanted to point you out to back to the web page, just to show you that we have currently 3 subscribers and we have 3 videos. I'm putting those videos into a lesson plan. So I'm building a playlist, and in this playlist, when you click on the playlist, you would be able to see lesson 1, lesson 2, lesson 3, and I'm going to try to build this into a longer playlist for whoever subscribes. But we need that number to become 1,000, and then YouTube will monetize me. And once they monetize me, I will tell you how much they pay me. I expect to get paid around between £1.50 and £3 per video, because each video has to have like 1,000 likes or 1,000 views. Plus I need 1,000 subscribers, otherwise they won't monetize me. I hope you enjoyed the video, and I will see you in the next lesson.